Well, thanks, Rudy. There's a lot to be said for someone with a creative mind. For some students in the United States, their creativity is paying off big time. An experiment they developed for NASA scored them the opportunity of a lifetime. In part one of his series Zero G, Michael McManus introduces us to 4 young scientists preparing to test their experiment in the ultimate lab.
These students are preparing for the ride of their life.
I can't even imagine what it's going to be like.
I've never been west of the Mississippi.
I didn't take them seriously until I got an email from NASA.
Izara's email let her and 3 other Tufts University students know their experiment had been accepted by NASA.
This is our test module, and this will be going up on the NASA KC-135.
The KC-135 Scott's talking about is the plane NASA uses to train astronauts in a weightless environment, or zero gravity. The testing module is what's giving the 4 students the chance to fly the plane. NASA chooses experiments from colleges around the country based on strict criteria, such as scientific merit or originality of experiment, feasible design and testing, and education dissemination, or what scientists and educators will gain from the project. Scott McNamara helped spearhead the group's bid to fly.
What we have is a box of air, and what we'll do is we'll turn on the fans inside the box once we enter Zero G on the plane.
Once the fan is on, water droplets will then be sprayed into the box to see how they react to turbulent anti-gravity. The rig, as it's nicknamed, is built out of metal, plastic, glass, and Legos. Together, it has unique scientific purposes.
What's the acceleration only in X?
One is cleaner exhaust by more efficient fuel combustion.
Gas prices are up like 15 cents from what they were 6 months ago. If we could make more efficient cars, then the prices would stay the same, but you wouldn't have to buy gas nearly as often.
The other is cleaner air by removing dust and particles from spacecraft cabins.
You know, the space program, be able to use it with cleaning the air, the agglomeration of the water particles will allow us to clean the air in the space shuttle.
Though the students would like a real-world application to come out of the testing, data findings and research are just as important to them.
To be realistic, those are long shots compared to the pure science knowledge that we and other scientists will gain from a successful experiment on the Zero G flight.
Every day I learn something new, and that's what I like about being in the lab, is just picking up new skills, learning a lot about electronics and machines and computers.
Chris Rogers is the student's teacher and mentor.
You never really can understand anything until you actually step in it. So by actually experiencing it, they definitely start to realize that all of the equations and the math that they've learned all along actually have some use and are paying off.
A payoff that's earned the students a trip to Johnson Space Center, home of the KC-135 aircraft, otherwise known as the Weightless Wonder. Michael McManus, CNN Newsroom, Medford, Massachusetts.
We've all dreamed of orbiting the Earth and floating weightless. About the closest most of us have gotten to it is being underwater. But some kids in Houston, Texas got the next best thing, courtesy NASA. Newsroom's Michael McManus explains.
A typical runway, a typical takeoff, but not a typical plane. This is NASA's famed KC-135.
I got sick 33 times the first flight, 21 the second, and 15 the third.
And for good reason, also nicknamed the Vomit Comet. Nicholas Sada is interning at NASA and has flown the KC 3 times for Purdue University. He's had rough rides, but thinks the experience is worth it.
NASA performs a lot of research that people don't realize that it does. We perform aeronautics research, microgravity research, and this is a great example of a program that encourages that.
The Weightless Wonder has been flying since the U.S. shot into the space race. It's been influential in giving astronauts and scientific equipment a small taste of zero gravity before blastoff.
We can test a lot of things out that are going to go in space, make sure they work before we go through the expense of putting them in space and find out that they don't work up there.
This floating laboratory behind me is actually a modified Boeing 707.
Since 1957, NASA has flown over 12,800 hours of zero-gravity flight. The flight begins with a steep climb.
As long as we're pushing over the top of that arc, we create essentially a little orbit, and the airplane and everything in it, the fuel, the pilots, the people in the back, everything's weightless.
Zero-G lasts for about 30 seconds, and on any given flight, 30 arcs, or parabolas as it's more commonly referred to, will be flown.
Jack, hold this attitude!
That is, unless you're making a movie. Tom Hanks and his film crew flew hundreds of parabolas to shoot the scenes in the movie Apollo 13. But not even Tom Hanks gets on this plane with a ticket. Training is what pays the way.
Everyone who flies on the aircraft, on the KC-135, has to meet an FAA Class 3 flight medical with some NASA adjustments. Plus, everyone has to have a current physiological training card, or they've had to have a chamber ride.
Good morning. I'm Mike Fox, and I'm in the Life Sciences Directorate, and we want to welcome you here to Johnson Space Center.
As with any NASA mission, safety is top priority.
This part weighs 75 pounds, and we've padded the exterior.
Each experiment must pass a meticulous inspection by NASA staff before being brought onto the plane. Now, it's the students' turn.
One more turn around. Okay, can you tell me how many fingers the gentleman is holding
God.
up? Okay, look straight ahead. Can you see?
2, 3. I don't know.
This student just had a lesson in spatial disorientation, when your mind tells your brain one thing, your body another. Now it's time for the chamber ride.
We're going to remove your oxygen mask, and all of you are going to have a blast. And most of you are going to get euphoric and happy.
He's talking about hypoxia, when your body breathes more nitrogen than oxygen. The effects are rather intoxicating.
Some of you should be plugging in, you know, if you're dizzy and lightheaded.
And it depends on the person, but people have different effects. I got very happy, a little discoordinated.
It's teaching you to really depend on your instruments and not on your instincts, because they'll fool you sometimes.
The classes culminate with a written FAA test that all students must pass. Now there's only one thing left to do: fly the K-Bird. Michael McManus, CNN Newsroom, Johnson Space Center.
And you won't want to miss Mike and the gang fly the K-Bird.
That's right, fly weightless, that is. Find out how they fared in zero-G tomorrow, right here on Newsroom.
Until then, that's a wrap for us.
We'll see you tomorrow. Well, today is the day, the highly anticipated ride on the Vomit Comet. We'll do some research, too. Space may be the ultimate frontier, but very few people get to experience its effects firsthand. Well, some students in Boston are getting a taste of space, along with their morning breakfast. Michael McManus explains.
The experiment is complete and ready to fly. The students from Tufts University have passed all the training and exams. After some tightening and safety checks, it's time to experience zero-G.
We're approximately 30,000 feet over the Gulf of Mexico, ascending at a 45-degree angle. As the plane levels off and begins descending, zero gravity begins. And this is when the students' research and experimenting can begin. Tell me what's happening.
Well, we're going to lift it up, and once we see that there's no accelerations on it, no G's, we're going to start from here. That's when we're going to squirt the water in.
Accelerations or gravitational pull leave the rig once the 75-pound, 34-kilogram experiment floats away from the cabin floor.
We have a camera here that's recording the water particles and what they're doing. What we're hoping is that the water particles in the box will agglomerate.
Agglomeration is the tendency to stick or come together, but unfortunately the water isn't cooperating.
What do you see in there?
Yeah, they disappear right away.
Rebecca has the same problem when it's her turn.
So far, we're shooting a lot of particles in the box, and they don't seem to be forming streams or managing like we expected them to.
Scott has a theory why.
The light we use to illuminate the test section is really warm, so we have very small water droplets, and that causes them to, what we think, to evaporate.
When shown later on, the video recorded on the rig shows the theory is correct. The water isn't cooperating, but the zero-G forces are, and it's a long way from Earth's gravitational pull.
This is amazing.
The parabolas or roller coaster-like arcs come and go, and before we know it, we're back on the ground. But not too soon for AJ.
I started to feel nauseous on pretty much the first parabola, and after the sixth one, I was worthless.
He was strapped in his seat most of the flight, but AJ still thrilled.
Even though I was sick most of it, I'd do it again just for the experience.
Izara was able to beat her nausea.
Felt great. I think if anything, it was the first parabola that made my stomach feel a little bit queasy, but after that, I think the adrenaline rush that you get from being weightless overrides everything else.
Everything is so hands-on and so deliberate and so tangible. It was really exciting.
It's just an incredible experience that most people will never, will never have the chance to experience in their lives. And like, people do these things, and we got a chance to do it, and it's just awesome.
Though a once-in-a-lifetime experience, AJ, fresh off the plane, is already looking for solutions to the rig's water evaporation problems.
We'll probably try to test out some method of either cooling the section or of using larger droplets.
Zero-G is over, but test director John Yannick hopes students take home more than just research.
And if it gets them really excited about the work that we do here at the Johnson Space Center and within NASA and our other centers, they may want to come to work for us someday and maybe become an astronaut.
Everybody ready? Ready?
The college flight program has been so successful, administrators are starting similar programs for high school students. Tufts University wants to go one step further and bring zero-G to an even younger group.
We've been talking about perhaps working with K through 12 kids and letting them make their own experiments that will be brought up on the KC-135 by students like us, and letting them view what happens to their experiments in zero-G.
NASA's newest mission calls for students to take a renewed interest in space and science. The space agency wants young people to know if you have the right stuff, they want to hear from you. Michael McManus, CNN Newsroom, Ellington Field, Houston, Texas.